Now, to answer this kind of question, you have to remember to follow these steps. Okay, the first step would be to identify the three things. Okay, three things ni iaitu the first one, apa yang berada dekat tengah-tengah dan apa dua benda yang keliling benda yang dekat tengah-tengah tu. So kita baca dulu soalan. The average orbital distance of Mars is such, knowing that the Earth's orbital radius is such and it orbits the Sun in approximately such days, use Kepler's third law to predict the time for Mars to orbit the Sun. Okay, so lepas kita baca, kita dah kenal pasti the three things. The center in this case would be the Sun. Okay, two planets that are orbiting the center would be the Mars and the Earth. Okay, so lepas kita dah identify, we can do step number 2, which is to draw. Okay, bila kita draw, kita akan lagi senang untuk kira sebab kita tahu apa yang kita nak cari. Okay, so bila kita draw, okay, so the center would be the Sun. Okay, and then kita akan ada dua planet yang keliling the Sun. So the first one, kita lukis orbit dia. Okay, the first one adalah, dan the second one adalah Mars. Okay, so Mars kedudukan jauh sikit daripada matahari. Okay, Mars. Alright. Now we are done with step number 2. Kita buat step number 3 pula. Kita list down information. Okay. So the first information it gave us is the average orbital distance of Mars is that. Okay. So orbital distance is just orbital radius. Okay, it's the same thing. So orbital distance is R of the Mars. Okay, kita symbolizekan dengan M, is equal to 2.28 times 10 to the power of 11 meters. Okay, knowing that the Earth orbital radius is such, so R of Earth is equal to 1.5 times 10 to the power of 11 meters, and it orbits the Sun in approximately 365 days. So maksudnya T, orbital period of the Earth, is equal to 365 days, which is a year. Okay, use Kepler's third law to predict the time for Mars to orbit the Sun. Okay, so yang kita nak cari adalah time for Mars to orbit the Sun. So T for Mars. Okay, orbital period of Mars. This is what we want to find. So lepas kita dah listkan semua information yang dia dah bagi dan apa benda yang dia nak kita cari, okay, so kita boleh buat step yang terakhir iaitu plug in to formula. So kita guna formula yang kita dah listkan kat tepi ni dan kita masukkan je. Okay, so T1 dan R1 kita wakilkan dengan Mars dan T2, R2 kita wakilkan dengan Earth. Alright, so T1 would be whatever we want to find lah. Okay, so this is what we're going to find later. And then T2, okay, which is the orbital period of Earth would be 365 days square, is equal to R1, which is R of Mars, 2.28 times 10 to the power of 11 cube, okay, divide by R2, which is the R of the Earth, so 1.5 times 10 to the power of 11 cube. Alright, so untuk cari T of Mars, kita mesti buatkan T tu jadi subject of equation. The rest of the values kita mesti put on the other side of equation. So kita akan dapat something like this. So kita tengok dekat sini, value yang sebelah kanan equation ni adalah untuk T square. Okay, tapi kita nak T sahaja. So macam mana nak hilangkan square tu? Kita mesti darab both sides dengan square root. Okay, so bila kita darab both sides dengan square root, yang tu dekat sini akan jadi 1. So kita potong. Dan belah kanan ni kita akan jadi square root of the whole thing. Okay, so bila kita masukkan dalam calculator, right, kita akan dapati masa yang diambil oleh Mars untuk keliling satu matahari adalah 684 days. Okay, so that is the answer for T and T of Mars. So for question 2, kita akan buat steps yang sama. Alright, so the first thing is we identify 3 things. Okay, 3 things tu being center, apa yang berada di center. Okay, so dalam kes ni, kalau kita baca soalan dia, Titan, the largest moon of Saturn, has a mean orbital radius of such. The orbital period of Titan is such days. Hyperion, another moon of Saturn, orbits at a mean radius of such meter. Use Kepler's third law of planetary motion to predict the orbital period of Hyperion in days. So this time kita nampak term-term yang maybe kita tak berapa familiar, tapi it's just actually a twist to the question. Okay, so kalau biasanya the center of planetary motion, biasanya kita tengok the sun, tapi in this case the center is actually Saturn. Okay, Saturn ni adalah satu planet yang sangat unik kerana dia mempunyai banyak bulan. Okay, bulan-bulan yang mengelilingi planet dia. Okay, so lebih kurang as of last year, lebih kurang 82 bulan telah ditemui. Okay, antara bulan-bulan dia yang paling famous adalah Titan dan Hyperion. Okay, so kita tahu kalau bulan ni fungsi dia adalah untuk mengelilingi planet. So the center in this case would be Saturn, and two objects ataupun two things that would orbit around the center would be Titan and Hyperion. So now that we have identified the three things, we can start to draw. Okay, so tengah-tengah would be Saturn lah. Okay, planet Saturn, dia ada ring, alright. And then Titan would be one of the moons. Okay, Titan tu akan mengelilingi Saturn. So this is Titan. Okay, satu lagi moon yang dimention dalam soalan ni adalah Hyperion. Alright. Good. Now kita dah berjaya draw. Kita move on to the next step. Okay, which is to list down information. Alright. So the first information dia cakap, Titan has a mean orbital radius of 1.22 times 10 to the power of 9. Okay, this is to the power of 9. Right, so R of Titan is equal to 1.22 times 10 to the power of 9 meters. Okay, the orbital period of Titan is 15.95 days. So T of Titan would be 15.95 days. Okay, apa lagi maklumat dia cakap? Hyperion pula, radius of orbit dia pula adalah 1.48. So R of H, Hyperion, 1.48 times 10 to the power of 9 meters. And then soalan dia, use Kepler's third law to predict the orbital period of Hyperion. So T of H, T of Hyperion is what? Okay, that is what we're going to find. Okay, so after kita dah list down all information, so we can start to plug the information in the formula. Okay, so kita drag formula ni masuk sini. So 1 would be Titan, 2 would be Hyperion. Okay, so T1 is 15.95 days square, right, bahagi T2, T Hyperion. Ini yang kita nak cari. Okay, equals to R1. So R1 is R Titan, 1.22 times 10 to the power of 9 meters cube over R2 cube. So R2 is R Hyperion, 1.48 times 10 to the power of 9 cube. Alright. Jadikan, kalau kita nak cari period of Hyperion, kita mesti jadikan T ni adalah subject kepada equation. So maksudnya kita kena tinggalkan dia seorang-seorang. So it will be something like this. Lepas kita dah tukar-tukar tempat, kita boleh dapatkan value of orbital period of Hyperion. But this is still square. So again, kalau kita nak hilangkan the square, kita mesti square root both sides. So this one will become 1 and the whole thing in this side will become punca kuasa 2. So bila kita plug in dalam calculator, kita akan dapat jawapan dia adalah 21.3 days. Maksudnya, tempoh masa yang diambil oleh bulan Hyperion untuk mengelilingi satu planet Saturn, Okay, adalah 21.3 hari. Okay, so in conclusion, kita boleh guna formula ni untuk any case. Tak semestinya the sun should be the center. Okay, it could be a planet. Okay, so ada banyak possibilities. Yang penting kita tahu apa nak buat bila jumpa soalan ni. Okay, guna 4 steps senang ni.